welcome to Math Master. This is Saritha. Today we are discussing circles topic continuation. Yes. So I am taking one point. Now you tell me how many number of circles can be drawn through a single point. Now you try. See, I am drawing and this is one circle, isn't it? And this is another circle. Yes. And this is another circle. If you keep on going drawing a circle through one point, so you will get an infinite number of circles, isn't it? See, you can draw like this and you can draw like this, because all you need to do is, and we have to draw a circle through that point. Yes, there are infinite number of circles can be drawn through a single point, isn't it? So, and how many circles can we draw through 2 points? See, there are 2 points in a plane. Now you try how many circles can you draw through these 2 points. Means our circle must pass through these 2 points. Okay. So now I am trying. Yes, this is one circle. Okay. And this is one more circle. Isn't it? And this is one more circle, isn't it? Yes, if you keep on drawing circles through these 2 points, you will get an infinite number of circles, isn't it? Through one point, we can draw infinite number of circles, and through 2 points also, we can get an infinite number of circles. Now, I am taking 3 points which are non-collinear points. See, these three are non-collinear points. They are not on the same straight line. These 3 points are called non-collinear points. Now I am considering these 3 non-collinear points in a plane. Now I am drawing a circle. How many number of circles can we draw through these 3 points? Means our circle must pass through these 3 points. Now you try. So I am drawing. Okay, this is one circle. Is there any other possibility to draw a circle other than this? It is not possible, because through any 3 non-collinear points, we can draw only one circle. Okay, through 1 point, we can draw infinite number of circles. Through 2 points, we can draw infinite number of circles. But if you consider 3 non-collinear points, our circle is only one circle can be drawn. Okay. Yes. If you consider these 3 points as a collinear points, means those 3 points are on the same straight line. Yes, these 3 are collinear points. Now you draw a circle which is passing through these 3 points. Is it possible to draw a circle? No, right? Because these 3 are collinear. If you take these 2 points, this circle is not passing through this point. Yes, if you consider these two and it is not passing through this, it is not possible to draw a circle with 3 collinear points. So if you ask the question that how many circles can we draw through 3 collinear points, then your answer will be 0. Okay, we cannot draw even a single circle through 3 collinear points. These are the number of circles through 1 point, through 2 points, through 3 collinear points, through 3 non-collinear points. Okay. Now we will discuss what are concyclic points. Okay. Concyclic points. What are concyclic points? Concyclic points are nothing but the points which are lying on the same circle. Yes. See, in order to draw a circle uniquely, just now we have seen that we need at least 3 non-collinear points. Yes, those 3 always lie on the same circle. That is why those are always concyclic points. But in order to say more than 3 points, 4 points are greater than 4 points, are said to be concyclic, then those points must be lie on the same circle. See, this is a circle. Now, I am locating some points on the circle. Okay, A, B, C, D, and somewhere here E point is there. Now you tell me what are the points which are concyclic points. See, these A, B, C, D are concyclic points because those 4 points are in the same circle. But when you consider A, B, C, D, E, those points are not concyclic because E is outside the circle which is not on the circle. Okay. So in order to say the concyclic points, we need at least 4 points because 3 points are always concyclic points only. That is why the number of points which are required to say those are concyclic are 4. Okay. Chord of a circle. Chord of a circle. What is a chord? See, if you take a circle, if you join any 2 points on the circle, see, this is one point on the circle, this is one more point on the circle. If I join these 2 points, now this can be called as a chord of a circle, isn't it? Yes, a line segment which is joining the any 2 points on the circle. This circle has infinite number of points, isn't it? So in those points, if you join any 2 points, there means the joining of those 2 points is a line segment. So that line segment we call it as a chord of a circle. Yes. This is one point, this is one point. Now I am joining this. This line segment is called chord of a circle, isn't it? And see, this is one point, this is one point. This is also we call chord of a circle. And see, this one, this one. Yes, this is also a chord of a circle. Now tell me, how many number of chords can we draw to a circle? As the circle consists infinitely many points, we can draw infinitely many chords also, isn't it? So we can draw infinitely many chords to a circle. How many chords can we draw through a point on the circle? See, I am fixing a point. This is a point I am fixing. Through this point, how many chords can you draw? Yes. Now I am trying to draw chords. Yes, this is one chord. This is one chord. This is one chord. This is one chord. See, if you keep on drawing, you can get infinitely many chords, isn't it? So through one point, you can draw infinitely many chords to a circle. Okay. Now we have seen what is a chord. See, if you join is a circle, this is the center of the circle. A chord which is passing through the center of the circle, that chord we call it as a diameter of a circle. See, this is a center and this chord is passing through this center. Yes, as this is passing through the center, this chord we call it as a diameter of a circle. Yes, this is a diameter of a circle. Now tell me, how many diameters can be drawn to a circle? See, means that chord must pass through center of the circle. Yes, okay. Yes, this is also passing through the center. This is also passing through the center. This is also passing through the center. Yes, we can get infinitely many diameters are possible in the case of a circle. Means there are infinitely number of diameters can be drawn to a circle. Okay. If you take a circle, see, this is a circle. Now this is the center of a circle. I am considering one point on the circle. Yes, this is a point on the circle. Now you tell me how many diameters can we draw through this point? Yes, that chord must be passed through the center of the circle as well as point on the circle. Now how many number of diameters can we draw through this point? We'll check. So this is the one diameter. Yes, we can draw through any point on the circle. Is there any other possibility to draw a diameter other than this? It is not possible because as it must pass through the center of the circle and it must pass through the point on the circle. So this is the only one possible way to draw a diameter through a point on the circle. Okay, you see, just now we have seen we can draw infinitely many chords to a circle. Yes, these are all chords of a circle. Among these chords, which chord is the longest chord? See, the chord means the diameter of a circle is always a longest chord of a circle, because the diameter is itself is a chord because it is passing through the center of the circle and it is itself is a diameter and it is itself is a chord, means the longest chord is always a diameter of a circle. Okay, so if you consider other chords which are always the length of the other chords are less than the length of the diameter of the circle. Okay, if you take a circle, this is a circle. See, this is the center of a circle. Okay, this is the center of a circle. Now, I am drawing a chord here, which is parallel to the diameter of a circle. Okay, so this is one chord, and I am also drawing other chord, which is like this. Okay, now tell me which chord is the longest, which chord is in the longest distance, which chord is in near to the center. So this is the center. Now you have to consider the distance. This is the distance d1. Yes, and this is the distance d2 of this chord. Yes, now which chord is nearer, which chord is farther? See, the and you have to, now we are comparing the length of the chord with the distance with the center. See, as this chord is longer in length, yes, this chord length is obviously greater than this chord, isn't it? See, if you take this AB chord and this is CD chord, now AB chord length is greater than CD chord. See, isn't it? And if you see the distances, the distance D2 is greater than D1, but D2 is the distance of the smaller chord, D1 is the distance of longer chord, isn't it? So we have a relation that always the longer chord is nearer to the center and shorter chord is always farther to the center. So did you understand? When you compare the distance from the chords, always longer chord is always nearer to the center and shorter chord is always farther to the center. Okay, and always we consider the distance is nothing but a perpendicular distance only. See, this is a perpendicular distance from the center to the chord and this is a perpendicular distance from center to the chord. We always consider a perpendicular distance when we compare the distances. Okay, and you see these are all different properties of chords. Okay, now we are discussing all the properties of a chords. These statements are very important. See, this is a circle, this is the center of the circle. Now if I draw chords of equal distance. So length means this is a chord AB and this is another chord CD. Now this AB length all is equal to CD length, means the lengths of the chords are equal. If the lengths of the chords are equal, then the distance from the center to the chord, we have to consider perpendicular distance, right? This is a perpendicular distance from the center to the chord, and here also this is a perpendicular distance from center to the chord. So automatically these distances are also equal. If the lengths of the chords are equal, they are equidistant from the center of the circle. Okay, now you got the point. I am considering two equal chords. They are always equidistant from the center of the circle. Okay, yes, this distance and this distance is equal. Okay, in this circle, you take any chord. This is the center of the circle. You draw any chord. So not only this, you consider any chord in the circle. So if you draw a perpendicular bisector of this chord. So this is a AB chord. Now if you draw a perpendicular bisector of this chord, what is a perpendicular bisector? A line which divides this line segment into two equal parts and which is perpendicular to this line segment, isn't it? Yes, this is the midpoint of this line segment AB and it should be perpendicular, right? Yes, this is perpendicular. Now this line we call it as a perpendicular bisector of a line segment AB. So what happens? This perpendicular bisector is always pass through the center of the circle. See, if you extend this always pass through the center of the circle. This is the property of chord. Yes. If you draw a perpendicular bisector of any chord in a circle, that will always pass through the center of the circle. Okay. Next property is, this is the circle and this is the center of the circle. So if you draw a perpendicular through the center of the circle to any chord. See, this is a chord of a circle. I am drawing a perpendicular through this center of the circle to any chord. Yes, I have drawn a perpendicular. So what happens? This perpendicular divides this chord into two equal parts, isn't it? If this is a AB line segment and this is the point N, then always AN is equal to NB. So this is one more property of a chord. Have you understood? See, if you draw a perpendicular through the center of the circle to any chord, not only this chord, if you consider chord here also or here also, here also, you can consider any chord. If you draw a perpendicular through the center to the chord, then this perpendicular divide the chord into two equal parts. Okay, means it bisects the chord. Yes, this perpendicular bisects the chord. Now, our next property is, if you draw a parallel chords, means all chords are parallel. If you draw like this, these are all parallel chords of a circle. Okay. So there are infinitely many parallel chords in a circle, right? So if you locate the midpoints of all chords, these are all midpoints of all the chords. This is the midpoint of this chord. This is the midpoint of this chord. If you so on, these are all midpoints of the chords of a circle. If you join these midpoints, this is always a diameter of a circle. Means this must pass through the center of the circle and this represents a diameter of a circle. So if you join all the midpoints of a parallel chords, that will always be a diameter. Okay. Length of a chord. See, if you consider a circle, This is a circle and this is the center of the circle. Okay. And this is a chord of a circle. Just now we have seen that if you draw a perpendicular through the center to the chord, this is a AB chord, and if you draw a perpendicular, this divides this line segment, this chord into two equal parts, means this AN is equal to NB, isn't it? And if you, this is any point on the circle, isn't it? So if you join center of a circle to any point on the circle, what will we get? We will get a radius, isn't it? If you join center of a circle to the any point on the circle, this represents radius of the circle. This represents a radius of the circle R, and this we call it as a distance. Yes. Now we have to find length of the chord, which is nothing but AB length we have to find out. If you know this, you can know AN also, isn't it? So as this is a right angle triangle CNB, so in triangle CNB, this is a right angle triangle. We have a property that if this is a length of x, yes, this is also a length of x, isn't it? Yes. What is the relation among those? R square is equal to D square plus x square, isn't it? So, but we want the value of x. X square is equal to R square minus D square, and x is nothing but under root of R square minus D square. So if you know the x, you can find out AB length, which is nothing but AB is equal to 2x, isn't it? So this x is nothing but only the length of NB or AN. But we want the total length of the chord, that is AB. So AB is equal to 2 times of x. If we know x, we can calculate 2x value, isn't it? So this is how we can calculate the value of x, which is nothing but under root of, if we know the radius of the circle and the distance from center to the midpoint of the chord, then you can find out half of the length of the chord. Yes. These are all different properties of a chord, and we will discuss about arc in the next session. Okay. Thank you.